Hello students, today we will study about operations on set. There are 5 types of operations we can do on set: union, union of sets, intersection of sets, difference, symmetric difference, and complement. We can write union as A union B, intersection as A intersection B, difference of set A minus B, symmetric difference. This is the sign of symmetric difference, and complement A dash. These are mathematical signs for these all operations. Now let us take first union of set. What does it mean? All the elements of set A and B. All the elements of set A and B. Common elements are taken only once. We can write it as mathematically. Let's say A union B. X, where X belongs to A, or union is written as or X belongs to B. Mathematically, we can write union as A union B X for all X belongs to A or X belongs to B. For example, let us take an example to understand the union of sets. First, let we take set A 1, 2, 3, 4, and set B 2, 4, 5, 6. So again, these are the sets given: A 1, 2, 3, 4, and B 2, 4, 5, 6. Now we have to write A union B. We have to operate on both sets. What is the operation? Union. So what does it mean? All the elements of set A and set B, and common elements are taken only once. So all the elements of set A 1, 2, 3, 4, and all the elements of set B 2, 4, 5, 6, and common elements are taken only once. So and 4, 5, 6, 4 is also common, so it can be taken once, and remaining elements we can write this here. So this is our A union B. We can represent it by also Venn diagram. John Venn discovered Venn diagrams. This is Venn diagram. The rectangular box represents the universal set. It represents universal set. Now we have to represent both the sets A and B. This is set A and this is set B. This part is common. So set A has elements 1, 2, 3, 4, and 2 and 4 are common. So they can be written here 2, 4. And what does set A have? 1 and 3. So they can be written 1, 3. And B 5, 6. So this is representation of sets in Venn diagram. Who discovered Venn diagrams? John Venn. Now the operation A union B, we can represent it by shade A union B. So what is A union B? 1, 2, 3, 4, 5, 6 means all elements of set A and set B, means all this is set A and set B, and common elements are taken once, means the complete part is called A union B. This complete part called A union B. So this is first operation on sets A and B union. Now we move on to second, intersection of set, means A intersection B. What does it mean? First, intersection of set means all the common elements of set A and B. Means here it wants to clear all the elements of all common elements of set A and B, means 2 and 4. We can see here. Now how we can write it mathematically? A intersection B, where x belongs to A, and intersection means and union means or x belongs to B. We can write intersection of set mathematically as this. Now let us take an example. Set A has elements A, E, I, O, U, and set B set B has elements I, U, P, Z. Now we have to operate on both sets. What is the operation? Intersection between two sets. Here you can say common elements. What are common elements? These are common elements from both sets. So this is our solution. A intersection B has two elements I and U. How we represent in Venn diagram? We will see it. This is square rectangular box represent universal set. Now we have to represent set A and set B in Venn diagram. We know all the common elements means this part. This part can be written as A intersection B. Now we move on next topic, difference of sets. It is the set of elements which belongs to set A but not B. Means it simply means A minus B. The elements which belongs to set A but not B. How we can write this mathematically? Which belongs to set A means element belongs to set A but not B. X doesn't belong to B. This is representation in set builder form of difference of sets. Now we can understand this by example. Let us take an example of two sets. Set A has elements 1, 2, 3 and 4. And set B has element 2, 5, 6. Now we have to operate on both sets. What is the operation? Difference of set. Means the elements belong to A but not B. Means remove all the elements of set B from A. Remove all the elements of set B from A and write here 1, 3, 4. This is our solution. Means remove all the elements of B from A. This is difference between two sets. We can represent it in Venn diagram. Again, this rectangular box represents universal set. This is set A and this is set B. Now the common element is 2. It can be written here. Now we have to find A minus B. Means remove all the elements of set B from A. So this part remains. This is A minus B. This is the set B. This is the set B, which is removed. Now, similarly, we can say B minus A. What do you mean by set B minus A? Means which belongs to set B but not A. But not A. We will take this example and understand this. If we have to find B minus A from these both sets A and B, so remove all the elements of set A from B, means simple 2, and write the set. 2 is removed, so we can write 5 and 6. This is B minus A. We can represent by Venn diagram. This is universal set. Now B minus A can be represented by this part. This is B minus A. Some properties of union, intersection, and difference of set. These are the properties. I will also teach you how to remember this and how this rule follows. First, idempotent rule means you have to use the same set. Means A union A gives A. A intersection A gives again A. Identity rule. Same follows. Same set. A union phi. Phi is empty set. Again A. A intersection phi. Again A. So this rule follows it gives same set. This is technique to remember or keep in mind the rules. Here commutative rule means commute the sets. Commute this A union B, B union A intersection B, B intersection. But here it doesn't follow. The difference of set doesn't follow commutative rule. Okay. Now we move on next associative rule. A union brackets B union C. Here, if you have to remember this, just remember the line change brackets. Okay. A union brackets B union C. So you have to change the brackets. A union B union C and write as it is. A intersection B intersection C. So brackets A intersection B intersection C. Here also it doesn't follow associative rule again. So these are exceptions. Okay. Now distributive rule. Distribute the operation or sign. Okay. A union B intersection C. You have to distribute this over this. A union B intersection A union C. You have to distribute these in the brackets. Now this A intersection B union C. A intersection B, A intersection B and A intersection C. And union. Distribute the sign of difference in brackets. Here the difference of set works. Means difference of set follows the only distributive rule, not commutative and associative. Okay, these are some properties of union, intersection, and difference of set.